Okay, so we're doing a really weird thing. First off, being the first video of this channel, we're actually learning. We're learning how to read radar based on the title of this video, obviously. Um, we're just gonna use a classic supercell as an example, because what best example do we have? Um, so off the bat, I think we're just gonna follow the storm, and then we'll just kind of look at the characteristics we're looking for. And I'll let it loop one more time. So obviously off the bat, oh jeez, that is probably loud. Obviously off the bat, we have this hook or appendage, we'll call it, on the, what would this be? I think the south or the west side of the storm. And as we slowly progress it, you could slowly see it starting to push back into more clear air. You kind of see an appendage right there starting to form too. Push it back even more, and this one becomes more apparent. We look at velocity. Yeah, there's probably an inflow going on right there. So we'll probably watch the storm, and then as it slowly progresses, that hook is starting to become a little bit, or trying to become a little bit more well defined. And then just about, that's when the tornado warning gets issued. Yeah, the rotation's starting to kick up now. Hit that, and just about now, like you can see, this is starting to have that classic supercell structure. You have this general like shape of the storm, and then you also have the hook down here. And as you slowly progress, the rotation's starting to kick up. Storm relative, yeah, the rotation's definitely kicking up. And you start having this, yeah, the textbook supercell, and you keep going. Velocity, pretty good velocity couple. I think that's where yeah, that's where we reach a debris ball. You can tell there's probably a debris ball given that it was low precip first, not much of a debris ball, and then with CC correlating, yeah, there's definitely a debris ball right there. And we keep going, and that debris ball stays, and we keep going, and yeah, the well-defined debris ball. So it's mainly looking for tornadic supercells. It's mainly looking at structure on reflectivity. And then, of course, for velocity, you're looking for your couplets. Like, for example, right here. Right here and right there, yeah. We'll go back. I think right here is the best one to do this on. Now, we can determine also kind of rotation this way, too. You click on your strongest inbound or outbound winds. Basically, green in, red out. And we hit place marker here on your strongest on either inbound or outbound, and then you go to the opposite, outbound or inbound, click control, there we go, and we have our VROT and then our conditions. Our conditions are mainly just to say, hey, what's the most likely intensity of this, and that's basically based off of VROT most of the time. You can also use the icons that are in GR to do this. Remove marker. Reflect. Go back. Using this button right here, your hail icons, of course, we'll turn these on. Yeah, like right here, it starts telling you, hey, there's definitely something there. We keep going. And then definitely strong. Right there, it's basically saying, hey, this is on the ground. We keep going. And it's just basically saying, hey, this is a pretty strong tornado. You hover over it. TDS, it tells you your what it believes the EF is. I think here it tells you the same too. right there, same thing. It's just algorithm based, and it kind of just tries to say, hey, there's this, that, there's this here, there's that there. It's just, yeah, it'll give you some false ones once in a while, but that's okay. Yeah, of course you can also rely off your local storm reports. Let me see if there is one around here somewhere. Yeah, right there. There's another one. There's another one. There's a lot of ways to just say, hey, there's a tornado or not. You can also use PTDS, which is right here too. We'll actually two panel it to show you this. So we'll use CC and PTDS. PTDS is shortcutted as T, so just if you need the shortcut, there it is. And you kind of just slowly go along. I think 4-panel might be the best on this one. Maybe, but I'm not sure. Yeah, right here it starts saying this is valued from 100%. It's like CC basically, just a little more algorithm based rather than it being an actual product in by itself. This basically it's called the probability of tornadic debris signature. So it just tells you its confidence on there being a tornadic debris signature. Right here it's maxed out at 100, and it just kind of keeps going like that. Now with this product, you can also kind of draw paths with your maximum trail values, and this kind of draws you the path. So if you're ever just interested, you can also do that. But yeah, that's mainly what this is. We'll go over these buttons another time, but to more or less tell if there is a tornadic debris signature, you probably want to compare it with both PTDS, CC, and velocity. So like for example, this is a strong velocity couplet. It has a CC drop. This is likely a tornado because obviously also it's in a hook. So that's mainly just the basic rundown. You're just looking for CC drops, velocity couplets. Determining intensity is a whole different other thing, and that's a whole different other topic. But yeah, that's mainly how to just read this radar. Now for embedded squall lines, this one isn't really embedded, but I don't think there's an embedded one anywhere. Oh, right here maybe. Yeah, right here. You can kind of start seeing, yeah, there's a little couplet there. It spins up. These are really fast spin ups. It's just you gotta have a really good eye for them. And Stormload kind of helps out with that too. So if I were to have, actually we'll use this tornado warning. Storm motion. You can kind of see the couplet. Warnings, SVR. I think this one's gonna give me its storm motion. Yeah, right here. You can kind of see the couplet a little bit better. It also depends on your environment. If you have a really good environment conducive to tornadoes, and we'll kind of go over how to figure that out too, because that's a whole other process too with models and everything. You can just kind of figure out how you can, or how likely a tornado is possible in the environment and in the storm you have. I know this was very brief and just not as informative, But it should give you a really good understanding on what you're looking for and what you kind of should keep your eye out for. I'm not saying this is what happens in every scenario. Like, for example, in this line, this could have a hook like this, but just not produce a tornado. It just might be straight line winds. And then there could also be, like, yeah, like tornadoes just embedded in a line. That's harder to see. It just depends on your environment and all that. Obviously, there will be other videos that go in depth on environments. But that's the simple rundown on how to read radar, find specific characteristics of a tornado and all that. It's brief, but it should give you a good idea on what you should look for.